Okay, so welcome to the LabVIEW 3182 virtual instrument for your data acquisition system. So normally you'd have some sort of a program icon to type. We're not going to do that in this case. We're going to go to Computer. We're going to go to C. We're going to go to Design 6 LabVIEW. And then we're going to click on this. This is the virtual instrument. Now, make sure your box is on before you click on this, because as part of the initialization process, your virtual instrument is going to make sure that your actual instrument is connected. So I'm double clicking.
So anyway, we did basically a month of review. Right, we go through circuits and we say, okay, here's what's right. Then we did.
And here it is. So what you have is you have, I guess depending on how you count, either 3 or 9 virtual instruments. You have a temperature meter over here. You've got voltage channels 0, 1, 2, and 3, which are probably the first 3 on the left of your box. And then you have current channels 8, 9, 10, and 11, which are going to be those 4. In order to use the virtual instrument, you want to have your thermocouples attached, and you want to have all of your voltage and or current inputs attached. You want to create a place to put your data as a function of time. So you need to, in this folder over here, specify some sort of file on the desktop where you can temporarily store your files, your data. I'm going to use demo, D-E-M-O. And you can see now it goes onto my user file because I'm logged into this computer, and there's a file called demo. Each time you take data, you need to make sure that you have a different file name over here. When you want to write your data to the file, you press this button over here. That will enable storage, on-the-fly storage. So what we want to do, so continuing with our demonstration, in order to actually record data, you need to press this button over here, and then you'll see that it becomes enabled. You have to press off the label, and there we go. And to stop taking data, you want to press enable again. Now, for some reason, it's not, oh, I know why it's not taking data. It's because we haven't told it to take data yet. In order to take data, we want to run continuously, but before we do that, run continuously is this double arrow button over here. But before we run continuously, we want to figure out how many samples we'd like per unit time. So we can take data as quickly as 1 sample per second, or we can do it, this is not 4 per second, this is 1 data point every 4 seconds. For temperatures, if we're taking a half hour of data, we wouldn't want to take it 1 per second. We'd want to do a much slower data rate, so we don't have as many to deal with. Okay, now let's plug our thermocouples in. So we're going to plug the first one into 0, and we're going to plug the second one into 1. And realize that you can have up to 16. Also realize that your appliance is going to be sitting down here, and all of these thermocouples are going to be glued onto it. Okay, so let's take some data. Now, realize you have 16 active temperature channels now. If you want, you can left click and you can turn this plot off. And you can do these in order so that you only have the two or the ones that you're using. Now I'm going to leave 0, 1, and 2 on. 0 is active, 1 is active, 2 isn't active. I'm going to hit take data now, run continuously, and it'll take a second, and here we go. And remember, it's taking one data point every 10 seconds. So it's going to take a while for stuff to happen over here. Now I'm going to grab my thermocouple.
So what do you recommend as the better way of going about talking about it? Where you talk about just the continuous design of the
And
CA,
for whatever reason,
that
it's not
you found out
changing.
that the CA was going to work, so we there was something wrong with the CA. Do it that way, or do we say our first iteration of CA?
Let me try this one. Maybe my thermocouple broke. Let's try this one.
Then we did our first iteration and explain the whole iteration.
I would think the big picture down would work better. So, design 1, we tried to do a CEA followed by a CEA. Okay. Here was the design, here's what was flawed about the design. Design 2.
Well, that's all very interesting.
The CEA followed by CEA. Right. You know, here's the design for that.
Okay, let's stop this.
So in other words, embedding the...
Let's just for fun change this to 1 per second.
Right. So say I'm down to the small picture, right?
And now I'm going to start again, and let's see what happens.
Okay.
And it worked to what we were trying to accomplish, exactly.
Now it's going up.
Because it was wrong.
Okay.
It's going up the way it's supposed to go up.
Small picture of the CCA.
So maybe you do need to take it, take a lot of data.
Well, so
Maybe that's what you need to do. Now I'm going to grab the other one.
Overall design.
Within.
So what you did,
And you can see stuff change.
so what you're saying is I have a CE.
You can see the one that I let go
Right.
is going down,
Yes.
And
29,
you're saying,
28, 27, and the one that I grabbed went up
I'm explaining
to
the big
32
picture.
or 33
Now I'm
centigrade.
going in describing this design.
Yes.
Okay.
And so you-
All of
you
these
have the original
58,000,
design,
56,000,
design.
those
I would just
are
make this one work.
not active
I would
channels.
describe-
Notice my voltage channels aren't active either.
Then it would move on to the
If you
circuit.
want to take a picture of what the graph looks like, you can always hit print screen,
This one,
and then you can paste the picture of the screen into some other software program.
this
Now we're going to stop.
long. So we drove
Our
20
data should have been written.
27 milliwatts.
Let's go into,
Got it working with the right
where are we? We're on the desktop. So let's go into my desktop,
The only way we knew that
and I'm going to look at
was when we were unable to get.
demo 1. So I think what it does,
So I'm trying to figure
is
out how we should say that without
demo was the
saying,
first one
okay,
I
we
looked
did
at.
iteration one here.
I typed in, and then I started it and stopped it rather quickly. Let's go into WordPad. There's a little bit in here. 8 seconds worth. We'll deal with that in a second. Let's look at demo 1. Again, we're going to open it with WordPad. And in here, there's going to be a lot of data because I let it go for a while,
And you know, all these qualifiers.
or I let it take a lot of data. Remember, in that first one, we were taking data once every 10 seconds, and I wasn't really happy with the data we were taking because the temperature wasn't going up the way I expected it to. So maybe there was something wrong with that data taking rate. I don't know. It automatically created that demo 1. So that's my second set of data.
Well, so
Let's look at what's in our
that's
data
fine,
file.
except you need to be a little more, then there was something wrong. Say what it was
So-
that had to be changed.
This is one block of data.
So we designed this.
This is your
Then we discovered when we
time number,
redesigned the CCA
0,
that it needed more power.
temperature 0,
So we had to redesign
temperature
the CCA
1.
to consume less power.
All of these temperatures
That's
going
really all
from
you said, is just
that are at
foreshadow
56,000,
what you're
we
gonna-
haven't plugged into those, so those
we
are just
discovered
empty
the second
garbage
stage
data,
power, so this state needed less power.
channels 2
Okay,
through
then all
15.
you do, well, here's my-
Then I can
1,
go back to
2,
the-
That's
3,
all you gotta do is say,
4
this is why-
voltages,
this is why I
1,
would
2,
redesign
3,
Okay, okay,
4
I can talk about
currents.
how the-
Then you have your next block of data.
Designing the actual system.
Corresponds to time equals
That's
1
what
second.
makes sense to me. I just-
As time goes on, remember I grabbed the thermocouple, and you can see that that second temperature starts going up. You can paste this data into Microsoft Excel and process it, but you'll have to get rid of the garbage columns.
We designed it, as discussed later, we found out that this one needs more power.
When you leave your virtual instrument, do not save anything up here. Do not save anything up here. You don't want to change your virtual instrument. All of your file changing, your file management, your data saving takes place down here.
This piece.
And I guess we can cut that off.
So then